La diabetes afecta a 1 de cada 11 personas en el mundo. Puede causar ceguera, insuficiencia renal, ataques cardíacos, accidentes cerebrovasculares y amputación de las extremidades inferiores. El Grupo de Investigación en Óptica de la Universidad Jaume I de Castelló ha desarrollado un sensor óptico de nanopartículas capaz de detectar concentraciones de glucosa muy bajas, como las presentes en la lágrima de una persona, mediante puntos cuánticos de carbono fluorescentes.
Carbon dots, as the name suggests, are very small particles in the order of less than 10 nanometers. They are extremely small. By comparison, you need about 20,000 of these particles put together in a line to have the same size as the diameter of a human hair. They are basically made up of carbon atoms bonded together by chemical bonds. On the surface, they contain other chemical elements that bestow these carbon atoms with special photoluminescence properties that are very applicable in many fields.
La invención forma parte del proyecto de investigación Glucotir, financiado por la Unión Europea a través del programa Marie Sklodowska-Curie Acciones Individuales, que tiene como objetivo desarrollar una herramienta de diagnóstico de diabetes no invasiva que pueda integrarse en un teléfono inteligente tanto para su uso clínico como particular.
In this project, the main goal is to use these fluorescence carbon dots to develop a device that is able to determine or to measure glucose concentration non-invasively, in the sense that we will use tear samples instead of blood. And the goal is to help diabetic patients who are struggling with the finger pricking method to be able to use this device and monitor their blood glucose without a problem. The most important part of it is that we will integrate this method on a mobile phone so that it can use the functions of the mobile phone.
De esta forma se evitarían las molestias que comporta a las personas diabéticas tener que pincharse para medir su nivel de glucosa, y el uso del dispositivo móvil serviría para recolectar y manejar los datos de forma electrónica. Actualmente se dispone de un sensor de glucosa validado para su desarrollo y adaptación a aplicaciones concretas.
So with me here I have a prototype of this device that we'll be using. In the end, we'll have something like this that will be attached on a phone to hold the samples. And the main part of the sample holder is this one, where you also attach it to the main part of this holder. And then what you would need is an LED to produce the exciting light for the carbon dots in the sample. And then you start the application. You take the first image. And then the next part of this is to put the sample. Let's assume that these are the tear samples. Put this on the sample holder and then repeat the same procedure with an LED on. Now this takes the second image and the program calculates the intensity between the two images and displays the results on the screen. This is just a prototype for the demonstration. The last and final device will have very small sample holder that will not be a problem for people who will be using it.
La patente desarrollada está basada en una nueva forma de sintetizar puntos cuánticos de carbono basados en láseres ultracortos.
We use laser ablation to prepare these fluorescence carbon dots. This method is very suitable because it enables immediate functionalization of these carbon dots with boronic acid sensitive units. Because in our method we put these boronic acid sensitive units in the ablation material, and in the end we were able to produce carbon dots that are functionalized with boronic acid units that are very sensitive to glucose concentration, to very low concentration in the level of the concentration in human tears.
Las ventajas de la síntesis basada en láser son que permite el desarrollo de una nanotecnología verde y sostenible, porque no requiere un exceso de productos químicos y no produce necesariamente residuos. Por otro lado, la funcionalización de las nanopartículas es simple y eficiente, ya que se obtiene in situ durante el proceso de síntesis. Además, gracias al procedimiento de fabricación, los nanosensores no están bloqueados por ningún otro ligando químico o residuo que pueda causar efectos indeseados.
Most importantly, these carbon dots are green in the sense that they are non-toxic to the environment and to the human body. They currently occupy the center stage of many nanotechnology applications, including light-emitting diodes, solar cells, bioimaging and biosensing.
El proyecto Glucotir se está desarrollando en el Grupo de Investigación en Óptica de la Universitat Jaume I con la colaboración del Servicio de Oftalmología del Hospital General Universitario de Castellón y la empresa de telefonía móvil Becu.